Okay, we should be recording that. Yeah, I see the little red dot up there. Okay, so like I said previously, I am Matthew Defenderfer. I work here in with CINL and Research Computing. And today I'm going to talk with you all about and lead you all through a little example about BIDS organization and moving quickly into just a little bit of fMRI prep, so pre-processing some MRI data that we have available for you. So what is the workshop for? Basically, organizing and processing MRI data is very complicated, especially for people who haven't been doing it before, who haven't done it before. That in my experience, there wasn't a very good analog to this sort of data analysis or projects in undergrad unless you worked explicitly with MRI data. So it can be a little bit overwhelming for people who are very new to it. So the overall goal for it is to just set up a very basic workflow for downloading data, organizing it in a standardized structure, and then performing very basic pre-processing on T1 weighted, T2 weighted functional images. And we've got a few tools for that. So the tools that we've got are Xnap. Xnap is available to anybody at UAB that is scanning on the Prisma. It is essentially an online repository for all of the scans that you do at the Prisma, as long as you push it up to Xnap. It's very easy to use, so it actually saves a lot of time for getting scans off of the scanner after collecting them. You know, people who have done that know that that can take upwards of like 20 to 30 minutes if the Osiris computer is not in use. And it can take longer if you're waiting on people to use that computer and get off so that you can use it. So Xnap's a very useful tool because you can just after the session is complete, you can just send those scans up to Xnap and leave, and those will be available to you anywhere that you have internet access. Like I said, everybody at UAB has access to it, and there is documentation on the site. I'm going to give you a link to our documentation later on at the very end. And there is documentation on how to get an Xnap account set up and how to set up a project for you to be able to push your data to it. So that's the way that we have for storing data online and downloading it from the online server. The tool that we have for organizing and standardized structure is BIDS. So BIDS is that standardized structure. We have an automatic Python conversion tool to convert from raw DICOMs to BIDS structures. And we'll talk about that here in a little while. And then the basic pre-processing, the tool that we have for that is fMRI prep. It is what's considered a BIDS app. So it acts on data that is stored in a BIDS format. And it's very easy to set up once your data is in a BIDS structure. It's very easy to actually start using fMRI prep after that in a very basic way at the very least. Of course, there's a bunch of options in fMRI prep that you can read through and add to the pre-processing pipeline if you want to, but we're just going to cover a very basic version of it later on. All right, so I tried to actually access Xnap to give you all just a little overview of it previously, but unfortunately the internet in here does not actually connect to the Xnap server for some reason. I'm not entirely sure why. The wired internet does not, or at least the wireless does. I don't really know what's going on there, but I will have to skip that this time. So we'll go straight into BIDS. So what is BIDS? So BIDS is an acronym that stands for the Brain Imaging Data Structure. BIDS is organizing data in a folder. It is naming files, and it is documenting metadata, and it is facilitating reuse by your future self and others. What it is not, and I feel like there's a large there's a large misconception about what BIDS is and what BIDS isn't. BIDS is not a file format. So you are not converting from DICOMs to a BIDS file. There's no such thing as a BIDS file. You convert from DICOMs to Nifty files that are structured in a BIDS format. And it is not a data sharing platform. And it is also not a pre-processing or processing pipeline at all. So basically what you start with for BIDS is a series of raw DICOMs that just come straight off of the scanner. What you end with is a certain amount of raw data in a nifty format that is structured in a very specific file system and has a very specific naming structure. So you're not doing any sort of alteration to the data moving from raw DICOMs to a BIDS organized nifty system, okay? So what are the benefits to BIDS? One, data reusability. So trying to figure out another person's organization scheme for people who have done it is very frustrating because you're kind of going through wondering why did they organize it this way? I would have organized this in a different way. It's just very difficult to get a good handle on how somebody else organizes data and be able to use it effectively in a time efficient manner. Data sharing as well. So if you are sharing data with another lab or with anybody else in the program, having it organized in a standardized way makes it very easy for the other person to figure out where they need to go in the file system to get the data that they need. In addition, steady reproducibility. So for anybody else that's trying to reproduce your results, if your beginning data is organized in the same way that when they're using it as when you were processing it, it removes a potential confounds for people that are using the wrong files because they are confused about the organization system. Everything is in a standardized format, so people know exactly where to go to get the data that they need. It just makes steady reproducibility much easier. And essentially what it is, if we put it in a picture, what we want to do with BIDS is convert from a series of DICOMs for individual scans, such as what we have over on the left here. We want to convert that to a highly organized system over on the right. So it starts off with a project data set, and then you go in for each of the participants that have been scanned in the data set. They each have specific folders for different types of scans. So anatomical scans all go in one folder, functional scans all go in another folder, diffusion scans all go in another folder, so on and so forth. So you know exactly where you want to go. I want to go to subject 5. I want their T1 weighted scans. So you know that you just go into the project directory, go to subject 5, go to the anatomical directory, and find a scan ending in T1W here. It makes it very easy. You know exactly where you need to go to find the data that you need. So let's talk a little bit about the folder system. Give me just a second. I actually want to bring up the chat because I think, yeah. Oh my gosh. No, they don't mirror it over here. Okay. I just wanted to get it. Yeah.
You have 2 people in the waiting room. They're waiting to get it.
Oh my gosh.
Close the waiting room. Yeah. So see it hit all.
Yeah, need to do that. There. Zoom is a treat. All right. So let's talk a little bit about the BIDS folder structure here. So the BIDS folder structure, I went through it just a little bit just a second ago. You start off with the project directory at the very top. You then break down the data into the raw data, into the source data, and then into the derivatives. I'm noticing now that this is a very strange thing to call this folder. I usually call it nifty, but what they mean by the source data would have the DICOMs. The raw data has the BIDS converted nifty files in it. You can call this any other number of names that you want to make it less confusing for yourself, or just based on your preference. It's all fine, but this raw, or what I call the nifty directory, is going to be the BIDS formatted directory. So not the project directory, but this raw or nifty directory once you go into this directory, you'll have all of your subjects sorted out one by one. And then inside that, you'll sort it. If you have multiple sessions or you just want to have this extra directory layer in here, you can have the different sessions sorted out. If you do have multiple sessions, you do need to sort out by session number. Okay, you can't put data from session 1 with data from session 2 all inside just the subject directory. And then within the session directory here, or if you only have one session within the subject directory, you have all of these different folders that contain different types of MRI data. So all the T1s and T2 data are going to go in the anatomical. The diffusion data is going to go into the DWI. Anything that's bold related or bold adjacent is going to go into the functional folder here, and so on and so forth. It even has BIDS formatting for EEG, MEG, and PET data as well, and then behavioral data. So it's really just wanting to compartmentalize all of these different types of MRI scans and MRI adjacent files or other sorts of imaging files into their respective folders so that things aren't getting mixed together, making it much harder to find for anybody that's wanting to go in and find a specific type of data. All right. Then the last folder that I'm going to talk about in here. So you have the raw folder here. You also have a derivatives folder. So the derivatives folder contains anything that is derived from this BIDS sorted raw data. Okay. So that's going to contain the outputs from such as fMRI prep or FreeSurfer or FSL, AFNI, anything that you are doing to the data to alter it in any way or analyze it in any way, pre-process it in any way, all of that is going to go into a derivatives folder that has a similar structure where you have the subject name and then anything associated with that under it. Okay. So I've got a couple of questions from the Auburn folks. Never got a box link. That is very strange. I copy pasted all of the emails in. I will have to go in and I'll have to go in and look at that. I apologize for people from Auburn or from UA who didn't get the workshop instructions. I don't know exactly why that didn't happen. I don't know, maybe it cut out non-UAB email addresses. I don't know why, but it's very strange. I apologize for that then. I did not know that was going to happen.
The workshop instructions in the chat.
Yeah, so we can go through a little bit of those instructions whenever we get to the tutorial portion of it and talk about exactly the setup for setting up the BIDS converter, okay? Again, sorry about that. Okay, so we have the BIDS folder structure here, but what about the files that actually go in them? So as well as having a very specific folder structure, there is a very specific file naming system as well. So file names are just built out of using a series of key value pairs linked with hyphens and underscores, and that end in a specific suffix describing the scan type. So because of this, the hyphen and underscores are actually protected characters in the BIDS naming structure. So if your subject identifiers have hyphens or underscores in them, during the conversion, those are going to be removed, just so you all know about that. We had a little issue with that previously, but it got worked out. So just so you know, those are going to be removed from any subject names or anything like that whenever you are converting. So just an example of how these file names look, an example T1 weighted file name might look like this, where you have a key for the subject with the value being the subject name right afterwards, linked via a hyphen. An underscore will separate this key value pair for the subject from the session number. So you have the session key and the value being the first session 01. You have that then linked to another key value pair for run. If you're taking more than one T1 weighted image in a specific session, then you would include this run key, and any subsequent T1 that comes after that would have run 02, run 03, so on and so forth. And then it ends in the suffix telling you exactly what type of data that it is. It's T1 weighted image. There are a variety of suffixes for a large number of MRI and MRI Json files. And all of this can really be found at the BIDS specification documentation page to figure out which type of suffix you need to use for which type of data. I've got links to that here in the presentation. We can take a look at it here a little bit as well. So that's a very basic example of a T1 weighted file name. A bold file name, so a functional data, if you're doing a resting state functional scan, will have a very similar naming structure. So you have the subject key and subject key value pair, the session key value pair. You have included in the functional scan, you need to include a task key as well as the name of what the task is. In this case, it's just resting state, so task rest. For scans where you can also include a phase encoding direction, such as functional scans and diffusion weighted scans, you can add that into the name as well. And it's pretty suggested to do so if you are taking multiple resting states in multiple phase encoded directions. It's encouraged to put that direction in the name as well. And then like with the T1 weighted, the run number here. And then for this scan, it ends in bold. The suffix for it is bold. An example of diffusion would be something very similar to that. So you have the subject number, the session ID, and then the direction, the phase encoding direction, the run number, and then it ends in DWI. So you can see whenever you set it up, you can set these names for even different types of files to be very similar to each other. They're going to contain similar information. So the subject ID is required. The session is required if you have multiple sessions. The direction is encouraged for bold and diffusion scans. And then the run number is required if you're doing multiple of these runs in the same session. Okay. Some keys are required for some scan types. So all scans have to have the subkey and a suffix together. Functional scans do require a task key and a name. And then Spanico field maps require the direction. And you can see this if you, and then so all of these scans are going to be sorted into the specific folder that they belong to. So the T1 weighted image be sorted into the Xnap folder here. The bold image would be sorted into the func folder here. And then this diffusion scan would be sorted into the DWI image here. All right. And you can see that you might be wondering, well, there's a lot of things about these scans that I want to put into the name. How many keys are there to be able to be very specific about what goes on in these scans? I will talk about MRS here in a second. MRS is its own special case. So if you go onto the BIDS specification site, I've got the link right here for you. It has it sorted out into different sections for anatomicals, for functionals, for diffusion, for QMRI, for EEG, and everything else that you can really think of besides MRS. But again, I'll get to that. If you go there, you can look at the suggested naming schemes for all of these different types of files. So what I've got up here is an example for all of the different types of functional files that BIDS supports. You must have the subject with the subject ID. You can have the session with the session label if there's only one session. If you have more than one session, it's required to have it. You have to have the task with the associated label. Then you can include things like an acquisition type. a direction, a run number. If you're doing a multi-echo sequence, you can include the echo number as part of the naming scheme, and really any other type of thing. I think that the rec here is more of like a catch-all that I've used before to denote a specific thing about the scan that wasn't captured by any of these other task ID or by any of these other key value pairs. And then they all end in a specific suffix. So bold, you can have the bold Json files, which I'll talk about here in a second, the bold nifty files, cerebral blood volume, the single band reference volumes that come along with multi-band bold sequences are also their own files that will have the exact same name as their matching bold sequence, but just be have the SVRef suffix instead of the bold suffix. So on and so forth. You'll also have events files for event-related designs and block-related designs for functional data, physio, stimulus files, and all of these are really created during the conversion to a BIDS format. So I know that a lot of people here at UAB collect MRS data, so magnetic resonance spectroscopy data for people who aren't familiar with it. Unfortunately, there is no automatic conversion from the MRS data that you get off the scanner to a BIDS format. So and because of that, there's not actually a specific naming structure for MRS data. What I would suggest and what I've done previously when dabbling in it is to pick out specific key value pairs that you want for your MRS data and build your own naming scheme that's BIDS adjacent within your lab. So I would very much suggest including the subject name, the session ID, the acquisition type, because I know there's different types of MRS. There's different types of MRS sequences, so you can add an acquisition type. If you're going for different I'm far from an expert in MRS data, but you can build a series of key value pairs specific to you all that makes your data much more reusable, at least within your lab, moving from person to person. So that's what I would suggest for MRS data, but you're gonna have to do it manually, unfortunately. Or write your own custom script to do it. So sorry for people that do MRS, which I know is quite a few. All right, up to this point, are there any other questions that people have about the BIDS structure? Okay, we can talk about that is very strange, and that might be a thing to work on in office hours because I don't know what the specific error. Oh, it's on Mac. That is weird. You might have to do a specific install of NumPy from either Anaconda or from using pip. Or you might just need to change the source that you're downloading NumPy from. That might be an issue to work on in office hours. So I know that you're at Auburn, but they can come to research computing office hours. I can send out a link to the research computing office hours for UAB, and we can talk about it there. Event files. Regarding the TSV event files, could you maybe touch on how one might apply a higher level TSV event file that applies to all participants? Sorry if I missed it. Okay, yeah. So for the event files, every scan or every functional scan in a bit structure should have an associated events file with it. One thing that you can do is you're not going to, during the automatic conversion, you're not going to be setting up the events file at that point. You're going to essentially fill it out after the TSV has been created, because it's going to create an empty TSV for every bold file. So you'll fill it out once, and what I would suggest doing is having a script, set that as the master version of the events file, and then when you are converting subjects to BIDS, essentially copy paste that events file into the respective folders. So the only thing that you would need to do at that point is change the subject label to match the subject that you're copying it to. But everything else should be exactly the same, right? Because even if you have a multi-session design, if you're repeating the task across sessions, then you would need to change the session ID. But the task name is always going to be the same. The direction should be the same because it's associated with that specific scan. The run number should be the same, so on and so forth. So I hope that answered your question about it. Basically, there's not a way to say, here's a master TSV for all of these runs of the exact same scan. You need to associate essentially identical TSVs to each of the functional scans. So the sub and ses do need to reflect their respective subfolder. Yes, they must reflect the respective subfolder. So sub S01, anything labeled with sub S01 is only associated with subject S01. And you need to change that label every time that you copy it to a new subject. All right. Are there any other questions? I'll just wait for like a minute for people to type out any questions they might have while I take a drink. Okay. What is a Chiha account? Is this only for UAB people or can Auburn people access? So Chiha is the computing cluster that's stored here at UAB. I know that Auburn has their own computing cluster system. I think it's the Easley cluster is the one that was built in 2020. I don't know the rules for accessing that cluster at Auburn. I know everybody at UAB has access to Chiha. But that would be something to ask the research computing team at Auburn, who I have no idea who they are. If you do want to use Chiha from a different institution, if you have a collaboration with a primary investigator here at UAB, they can get you a temporary, what's called a Zias account. And we have documentation for requesting Zias accounts at the research computing documentation page, which I will provide a link to. Actually, I can just give you the link to that here, uabrc.github.io. If you go to that research computing documentation page, there is going to be under account management instructions for requesting a Zias account. But again, this is only for people who are not at UAB, who have a collaboration with a PI at UAB, okay? If you don't have a collaboration with a PI at UAB, then unfortunately you do not have access to the Chiha cluster. But like I said, Auburn has their own computing cluster system that you should be able to do all of this on. I can't imagine that you would not be able to do something like this on that cluster, computing system. All right, so I don't think that there are any other questions that I've missed. Okay, so we'll go ahead and move on. So along with each scan that's converted to BIDS format, there are things called JSON sidecar files that come with every single scan. So conversion from DICOM to Nifty causes really a net loss of information from the DICOM headers that could be useful to researchers down the line. So as a part of BIDS, what they require is extracting certain certain information from those DICOM headers and storing it in a JSON file. So a JSON file, if you haven't opened one up before or know what that is, it's a JavaScript object notation file. Basically, it's just a series of key value pairs that are organized in a specific way that give you all of the information that you could need about the Nifty file. All right, JSON files are very common in pretty much everywhere, but they're used to particularly good effect here in BIDS. So BIDS, BIDS requires that every scan have a corresponding JSON file with relevant metadata. There is a list of required metadata for manual conversion out there, but I'm not going to link that because I don't know where it is, and two, going and manually extracting metadata from the DICOM headers to store in the JSON files is a huge pain, and I would not suggest anybody do it, even for like practice or anything like that. It's just a huge time sink that can better be done using the automatic conversion tools that I'm going to show you later. Okay. The sidecars have the exact same name as the scan they're matched to, but instead of ending in .nii.gz, they end in JSON instead. So you'll see here in this example, the JSON file on top has all of the exact same key value pairs that the Nifty file could have, and it should match the name exactly, just ending in JSON instead of nii.gz. As a separate note about how these names are structured, any key value pair that is inside square brackets is not required. It is optional, and it's up to the researcher to decide whether it is necessary to include in the name. Anything that is not in square brackets is required. So for these bold files, it has to have the subject and the subject name, as well as the task key and a specific label for the task. So everything else here is optional. So as well as having these modality specific files, we also have modality agnostic files. So these are files that describe holistic features of the data set stored at the top level of the data set directory tree. So these include the data set description, which I've got a link there for more details on that description file. And then so inside the data set description, there's things like the name of the data set, the BIDS version, authors, acknowledgements, the DOI number, basically any sort of descriptive information about the data set or any papers that it was used in, and anything else goes in this dataset description.json file. There's only one. The tool that we use creates a very generic JSON file for this, but you will need to manually go in and edit it to change the information to make it specific to your data set. In addition, there's also participants files, both in TSV and JSON format. These participants files are very useful because they have been used to store information such as age, sex, handedness. For multi-group studies, you can add a group designation. Basically, anything that you think is useful information for the participants, you would store in this TSV or JSON format, JSON file. Okay. As far as the participants files go for sharing data, if you're going to include things like age, which can be identifying information, I would not include age in any participants. I would not include anything that could be potentially identifying any participants files that are being shared with people that are not specifically on the IRB. I know that for the HCP data, if you go and request that and do not have access to the restricted information, which you can apply for, but if you don't have access to the restricted information, you can get age information in age blocks. So from like age 18 to age 26, from age 27 to age 35, things like that. So if you wanted to make a second participants file for whenever you're sharing these data with other people, you could change the age from a specific number to a block instead. That's kind of up to you. Oh yeah. Yeah, having trouble downloading practice data from VoxLink. The data is pretty large. It's like 4 gigs. So yeah, that's why I sent it out earlier this week. Unfortunately, you didn't get it, which kind of sucks. Yeah, I don't really have a way around that right now. Besides just trying again and hoping it works. It might be a network issue where you are streaming the Zoom call and trying to download a large amount of data at the same time, as well as any other thing that you might be doing on your computer that might impact essentially the ability to download that data, do everything else at the same time. I'm not very sure. I'm not sure how to fix that, to be honest. But at the very least, if you are able to download the data later on, like I said, this is all recorded, you should be able to go through and do it later on if that's okay. Again, I apologize for everybody that didn't get that email at the beginning of the week. All right, so that is it for the modality agnostic files. So that's the very brief overview of BIDS, just to get you all kind of to get you all familiar with exactly what it is and what it does, and what you can expect as an output in whenever you're converting to BIDS. But now we should probably get into how you actually convert it. What tool are we going to use to actually convert to BIDS? And that is going to be the Python toolbox that I had you all download earlier. So it's a toolbox that stands for the Heuristics DICOM converter tool. It's a Python tool that converts DICOMs to BIDS formatted nifties, given a mapping heuristic that individuals will need to create on their own. It auto-generates all the JSON sidecars with basically all available metadata. So this is why I didn't really include a list of required metadata, because this tool grabs pretty much all metadata, and you don't have to really do anything to do that. So it makes it much easier than having to manually grab the correct metadata and include it in JSON files. It also generates generic dataset description and participants files for you all to go and edit later. One thing that is nice about it, though, is that as you convert individual subjects to BIDS formats, it adds entries for them to the participants' TSV files and JSON files automatically. It does not include the correct age, sex, handedness, or anything like that, because you're not giving it that information during conversion. But it does at least add entries for them for you to go and edit later. It also does not overwrite the participants files if you convert subjects at a later date. So you don't have to worry about earlier subjects' data being overwritten, you having to re-enter them if you start adding subjects later. So everything's just going to be added line by line into these JSON files and TSV files. And we can just talk about the general call that it's going to look like before we go into the practical portion. So the general call is just the name of the tool. I pronounce it HeuDiConv. I don't know how they want it pronounced, but that's close enough for me. The things that you need to give it as far as inputs go are the subject ID that is going to be inserted into all of the names. If there's a specific session that you need it stored under, you also give it the session ID. You have to give it the path to all the subject's DICOMs using the -D input here. The -O input refers to the output folder for where the BIDS formatted structures are going to go. -F corresponds to the heuristic file that you're going to use for mapping the DICOM files to what type of scan they are. So mapping them to functional scans and the type of name that you want, mapping them to anatomical scans, the type of name that you want for them, so on and so forth. And then the converter is going to be DC into NIIX. It's a older tool, but it still works extraordinarily well for converting from DICOM files to NIFTY files. And then -B just says to put it in BIDS format. I'm not sure why that's not just a default, since that's the whole point of the tool, but they wrote it, and you have to add that. So one note: session information can be excluded if the design only had a single scan session. So that's why it's in square brackets here. Again, anything in square brackets you don't need to include if you don't absolutely need to include, except for -B. I'll show you why this is in square brackets later, but you don't need to include the session ID if you don't want to, if you only have a single scan session. All right, so let's go ahead and exit the presentation for a little bit here. And we're going to go to, okay, it's still, wait, screen sharing is stopped because the external display is consistent. Oh my gosh. So, I see. All right, so for people who have submitted jobs for opening up the HPC desktop session, go ahead and go to your interactive sessions here. And it should, at this point, hopefully have launched that job for you. So you can just click Launch Desktop in the new tab. And it should open up something that looks like this. For people who haven't used Chiha very much before, this is, or an external computing system before. This is a virtual desktop for your account on that cluster system. This behaves.
I'm gonna go to my office.
Okay. This is essentially a computer that is just, oh, whoops, I keep on clicking wrong thing. That is just located in a different, on a different piece of hardware that you can access through a web browser. Okay, but it behaves exactly the same as any other computer, especially for people that have used Linux machines before. This is all Linux, so it's a lot of command line stuff, but it behaves very similarly to, like, people coming from Windows and Mac OS shouldn't have too much of an issue getting around. So we open up, we can click down at the bottom here, our file system. I've got a link here to my user data directory, but we can just go to it by typing in /data/user and then your username. So my username is in Defendi. That takes us to our user data storage, where in the instructions, that's where I told you to put the data downloaded from the box directory. So we'll just go into the BIDS workshop, into this WS workshop_data folder that I had to all create, and then a DICOM folder in here that's going to contain the raw DICOMs for subjects S01 and S02. So if we just want to take a look, just very briefly, get an idea of what type of data we're working with, we go into S01 for this person and for S02 actually as well. The type of data that we collected in this session, a small sampling of it is going to be 2 spin echo field maps that are going to be used for distortion correction for EPI sequences later on. We have 1 T1 weighted MP range scan for your anatomicals. A lot of sessions and a lot of designs also include T2 weighted scans, but that would have again bloated the file size. So we're only working with T1 weighted image here. We also have 2 resting state scans. So these folders are the DICOMs for the resting state scan itself. And it's going to be 420 volumes for resting state for each of them. And then you have the single band reference volumes corresponding to the each of the resting state scans. So these are multi-band images. So since they're multi-band, they have a corresponding single band reference volume that goes along. In addition, we also have one diffusion weighted image along with its single band reference volume, because again, the diffusion image is also multi-band. So in total, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 scans. Okay, because we treat the single band reference volumes as being separate from the their corresponding functional or diffusion scan. We have 9 total scans that we're going to be converting from DICOMs to NIFTYs. If we just take a quick look at here, you can see it has a whole bunch of DICOM files corresponding to that specific scan. We're going to condense all of these down into single NIFTY files. All right, that same structure is also found in S02, and we can talk about how to convert multiple subjects to BIDS format all at once later on. But for now, we're just going to work with subject S0. Okay, so in order to start it off, let's go ahead and open up a terminal down here. So in the terminal, for people who have already set up their environment and are using HeuDiConv, all you need to do, for people who are doing this on their own personal machines, you do not need to do this step because you should have access to Anaconda automatically. But for people on HeuDiConv, what you're going to need to do is use this module load command to load Anaconda 3 and give it the specific version of 2020.11. That's going to load a more recent version of Anaconda. I think it's Python version 3.8.5. If I remember right. There's a newer version on here, but I've just been using 2020.11 for a while now, and so until I have need to change that, and probably not. So after loading the module, you now have access to all of the conda commands. And again, one of the things that I had to do in those pre-workshop instructions is create a specific environment for storing the HeuDiConv toolbox in. So in order to activate that, for people who have done this already, you can do conda activate, and then we named the name of the environment BIDS. Okay, so conda activate BIDS. Execute that. It'll take just a second, but you'll know that the environment worked, the loading the environment worked, because you have the name of the environment to the left of the command line. Okay, so now we have access to all of the HeuDiConv toolbox and anything else that we need. I'm going to do one other thing in here because my setup is a little bit weird compared to others. Sometimes whenever you're installing this toolbox, it'll, instead of installing it directly into the environment folder, the environment directory that's created whenever you create the environment, it'll instead store the toolbox in your .local folder. So I'm just going to go ahead and add that .local folder to my path, because otherwise I'm not going to have access to the files that I have. So this line is going to do that. Path equals what the path was before, the value of the path previously, and then the colon just adds another path to it. So I'm going to add my home directory .local/bin. Okay, so it's adding the compiled binaries in the .local folder inside my home directory to the path. Even if the toolbox is downloaded to the conda environment, you can still do this command here and it's not going to change anything. So it's, even if you don't know exactly where the toolbox is stored, it's safe to just go ahead and add that .local binary path to your path, and it won't hurt anything. It'll only solve problems. So now I have access to the HeuDiConv toolbox. Let me just make sure. Chat. Okay. So at this point, there's a question. So give me just a second. Let's say you have a NIFTY files, but not DICOM files, but you need to put your NIFTY files into BIDS. When you run the HeuDiConv command, do you just put the path to the NIFTY files for the /d command? That's a very good question. I have not actually gone through and tried to convert non-BIDS NIFTYs to BIDS NIFTYs. So what I would say is that it might be possible, but what you need to do, and we'll talk about this when we write out the full command later. One, you don't need to say, you would say in /d, you would point to all of the relevant Nifty files. Two, you would not give DCM to NIIX as a converter. You would just say none as a conversion tool because you're not converting from DICOMs to Nifties. And three, we might need to alter the heuristic file a little bit, but I'm not entirely sure on that. That is a very interesting question that I don't have a concrete answer for. But it should be possible. The only downside to it though is, like I said, there's a lot of metadata that's stored in the DICOM files that are not, that's lost whenever you convert to Nifties. So if you're just converting BIDS formatted, or if you're converting non-BIDS Nifties to BIDS Nifties, you're not going to have access to all of that metadata. And in fact, I think that might be one of the reasons why HeuDiConv would fail here, is because it's trying to look inside the headers for the DICOM files, but those DICOM files don't exist. There are other tools out there, and if you're starting with Nifty files, it is possible to write a conversion tool for it. That would be a pretty long and in-depth process though. So it might be worth exploring other possibilities before embarking down that road. All right. Follow-up question. Let's say you organize your files into BIDS format, but you can't organize all of it at once. There's behavioral and physiological data that you haven't downloaded yet, but you do download that data later. Should you wait until all data is downloaded and then put it into BIDS, or add those files into BIDS later? So what I would say is that any scan data that you have, I would wait to convert scans all at once. But if you have behavioral data or text data or things like that, just spreadsheet data associated with those scans, you can convert those at any point because those are not actually being converted by this tool. That's what I would say. So as far as the physiological data though, I would say depending on how that physiological data is stored, I know that for some physiological data, you can record it and store it in DICOM files, and then as long as it's stored in DICOM files, those will be converted by this tool. So I would wait until you downloaded the physiological data that's stored in DICOMs to convert everything all at once. But if your physiological data is stored as TSV files, then you don't need to wait until you have the physiological data to convert, because the conversion tool here is not going to pick up those TSV files and convert. All right, awesome. Let me just scroll through just real quick, make sure. I don't think there are any other questions. Again, if you all have any questions at all, please just go ahead and put them in the chat as we're going, and I'll try and get to them. Okay. All right. So what we've got is our path file here. I'm sorry. What we have, we've added HeuDiConv to our path, both through loading up the specific environment and adding the .local binaries directory to our path, because those are the two places that it could be. So let's go ahead and run just the first step of HeuDiConv. There's really three major steps when you're just starting off, okay? So the first step that we want to do is generate a generic heuristic file, as well as generate a table file with all of the information about all of our scans in it, so that we can use it for matching in the next step, okay? So the thing that we're going to do is we can use, the first thing that we should do actually is set a environmental variable for where our dataset directory is. So that way we don't have to type out the full file path every single time. That's kind of annoying and I don't like doing it. So I'm going to set a variable for it. So our dataset directory is going to be this ws_data folder here. So this is where the DICOMs are going to be stored. This is where the BIDS formatted nifties are going to be stored. This is where the derivatives will be stored later on whenever we run fMRI prep. After I make a quick change to that script. So we're just going to copy paste this folder here. We're going to say export ds_path equals, paste there, and then enter. Okay. So now for in bash, I can reference this ds_path variable, and it will just replace it. Oh, I didn't know this touchscreen. It will just replace it with the path that I gave it, the path that I assigned to it. Okay. Export is how you assign variables in bash. For people who don't use bash, use bash as minimally as possible. It's very frustrating, but this is how you assign. This is how you can assign variables. Okay. You also could just leave out export and say ds_path equals that path. I don't know exactly what the difference between that assignment is. I think it's I think bash treats it differently, treats it a little bit differently, but either way, it should be usable. So next we can bring up. Let's bring up the function call that we had previously on our slides. Now I'll go ahead and zoom in here so we can see it. So it is the HeuDiConv name here. So start off with that. -s. So we're going to set the subject ID. So the subject ID in this case is going to be, if we go in here, S01. All right. It doesn't have to be the name of S01. You can set it up to where you could change the name if you wanted to, but I'm not exactly sure why you would want to. So I'm just going to set it to be the exact name of the person that we are converting here. In this data set, we don't have any session information. So it was all single session. So I'm not going to include a session tag in here. So I'm going to leave out the -ss option. The -d option is going to be the full path to all of the DICOMs for that subject. And it's going to be a little bit weird for people who haven't seen globs before in bash. So first off, we're going to start off with the value of ds path that we set earlier. So that's going to input the data user indefinity BIDS workshop WS data into the beginning here so that we don't have to type all that. And then the subject's DICOMs are stored in this DICOM file here. So we'll go ahead and add that. And then instead of putting the subject's name, we're instead going to put curly bracket subject and then in curly bracket. So what's going to happen is that since we set it up like this, it is actually going to input this subject name into this path right here. Okay. And this is one of the ways that we can make this reproducible and apply it to a bunch of subjects at once. The only thing that we need to change is this subject ID here, because that's going to be input into this subject curly brace here. After that, the path to the DICOMs, we're going to use a glob syntax here, which is star, and that's going to say every folder within this subject's directory. We want to go into every single folder within this subject's directory, just using that star. And then we're going to say we want every DICOM file, again using glob syntax. We want every single DICOM file within these scan folders. So we specifically say star.dcm because we don't want to include the .gif files that we might have, depending on how you downloaded your data. There can be some, or there cannot be some extraneous files that go into the folder as well. We only want the DICOM files, so we say star.dicom. That's all we need to do for the -D input. The -O input is going to be our dataset directory, so our ds_path. And I name the BIDS output folder nifty personally. You can change this to raw, you can change this to whatever you want that makes sense to you. I personally prefer nifty though. For this first step, for our -F input, we're just going to say convert all. We're not going to give it a heuristic file because we have not created one yet. So we're just going to say convert. The -C is going to be none because we are in this step, we are not actually converting the DICOMs to nifty files. We're just getting information and generating this generic heuristic file. And then we're going to exclude the -B input because in this step, we're not converting to a BIDS format. We're not converting anything. So we'll just leave it like that. And then we can say -- overwrite just in case there was anything that there previously. We'll just say -- overwrite. So we run this. If the tool starts up correctly, it should come up saying HeuDiConv version 0.9.0. Yep, running HeuDiConv version 0.9.0. It's telling us that the latest version is 0.10.0, but I personally have not tested that version out to see if there's anything wrong with it or how it works. So I just stick with 0.9.0 because it converts to the latest version of the BIDS specification just fine. I can do everything with it that I need to do with it. So I don't feel like 0.10.0 is very necessary for my purposes. And to be honest, I don't really even know what they changed in the versions. So if you all feel like you want to use the latest version, though, then you can download 0.10.0 and use that. But for this case, we'll just use 0.90. So you can see that the processing starts, the subject is set to S01, which is what we wanted it. The output directory has been expanded to where it includes the full dataset path here. So data user independent BIDS workshop, WS data nifty. And then the session information is given as none because we didn't have it. Okay, so that will only take about a minute. If we go out in our directory tree here, go up to the dataset directory folder, we'll see that we now have an output directory called nifty here that's been created during this process. If we go into nifty, and for people that haven't done this previously, if you go into a folder and there are some hidden folders that are stored in some directories. The hidden files and folders begin with a dot and are not by default visible. That's why they're hidden. If you want to show the hidden folders and files, you can click View in your tab here and click this Show Hidden Files option on. I already have mine on, so I'm not going to click it. But what you want is to go into this .HeuDiConv folder here. And we're going to go down and create a specific directory for our subject, for our info, and then it has created a DICOM info TSV file and a generic heuristic.py file. So it's a Python script. And what we're going to do is we're just going to cut and paste these into the dataset directory, the main dataset directory. So the second step for this is going to be to create the heuristic file that maps the DICOMs to the type of scan that they are and sets out the naming scheme that we want to use for the for each of the files. And just have chat. I'm going to check the chat for this. Yes, I can paste that command. First, let me just read through real quick. Does the length of the subject ID matter? Does it have to start with an S? It does not. You can have, for the value of the subject ID, it can be literally anything you want, as long as it does not contain underscores or dashes. And I guess it has to be alphanumeric because the file system sometimes doesn't like non-alphanumeric characters. I'm not totally sure on that. But yes, the length of the subject ID does not matter. It just has to not have the underscores and hyphens. Can I paste the command? Yes, let me go ahead and do that real quick. So I'll go ahead and say. All of this is also in the slides. This section here is in the slides, but I'm kind of just skipping over it since we're doing the interactive version. Wow, they added a couple things. So but I'll go ahead and paste it in the chat here as well. Okay. Is there a way to run this command for many subjects at once rather than just a single subject? Yes, there is a way to do it, and I will go over that here in a little bit as soon as we finish doing just one subject, since that's the easiest case. Now, I will say the way that I have created to do multiple subjects is really only usable on Chiha or a computing cluster that has a Slurm job scheduling system, but it is definitely possible to convert to just doing a for loop and running, creating a bunch of scripts at once and running all those scripts. That's how I would suggest doing it on a personal machine. But there's not a way just purely in the HeuDiConv call to say do subject S01, S02, S03, as far as I know. I don't think there is. I think it's just single subject. Just an underscore, got it now. My Nifty folder is empty. Looks like the command worked, so I'm not sure what happened. If your folder is empty, you might just not have the hidden files shown. So just click that on and see if the .HeuDiConv folder shows up in the Nifty folder. Awesome. All right. Yeah. It creates it as a hidden folder because technically what happens is that every time you run the HeuDiConv command, it recreates that hidden folder and creates a new directory for each subject that's run through it inside it. And they just didn't want that to clutter the BIDS formatted directory. And I'm pretty sure that hidden files and folders are not accounted for when you're validating your BIDS data set to make sure that everything is formatted correctly and stored correctly. I'm pretty sure it ignores all hidden files and folders, so they made it a hidden file so that you didn't run into any issues with that down the line. Okay, so the next step is going to be kind of the hardest and most work-intensive step of this process, and that is creating the heuristic file. So we can open this up and look at it. If you just double-click it in Chiha, I don't know if it brings it up in just like a gedit window, or if it brings it up in Atom, this viewer. I would suggest looking at it in Atom, which is if anybody's used like Notepad++ before, Atom or VS Code, Visual Studio Code, or PyCharm, or any number of useful IDEs for coding. Atom is just another version of that that's installed on Chiha by default. If you're using your own system, I personally really like Notepad++ or Visual Studio Code for people on Windows. Atom is available everywhere, but I would suggest anytime you're coding, just using one of those IDEs. If you want to use it and it doesn't open it up automatically in Atom, what you can do is go into Applications here, go to Accessories, open up Atom there from the menu, and then you can use File and open the heuristic .py file using that, or wow, that's gone. Or you might be able to just drag and drop it into the window and have it open up there. Okay, so once you open up the heuristic file, this is generally what you see. It looks like a lot at first, but realize that there's a whole lot of lines of comment here that are completely unnecessary. So even though it looks like there's 53 or 52 lines in it, don't be, for people who haven't coded before, don't be distraught or intimidated by the length of it. It's just a bunch of comments. So in the documentation that I put on for creating your heuristic file, the example that I put up there looks a little bit different from the one that you're going to see here. I've added a little bit of notation to that one, but basically what you're going to do is there's only specific sections of this file that you need to edit. The section that you do not need to edit is this one up here. Do not edit. So I'm just going to put a comment up here for people just to remind them. And that section is going to end after this first definition. All right. So don't edit especially do not remove the import here, and do not edit the create key function that's been defined here. Okay. You don't need to do anything with that. The places that you need to edit are going to be this small section here, where you're going to be creating keys for each type of scan that you have in your data set. And you're going to be editing inside this for loop that's going to be looping through all of the scans and matching them to specific keys. Okay, so let's just go ahead and start off with a very brief introduction to, or just like a simple example of what a key is. So in here, they've got a very generic key. So data equals create key. And then the name is just going to be run, and then 3 digits of the item that's assigned to it. And I will show you what that means here in a second. That doesn't mean anything to you right now, but I'll show you what that means here in just a second. So this is just a very generic way of creating a key. Now, what the keys are used for is for each scan needs to be assigned to a key, and the key is giving it the structure of what the file name is going to be. So this is where you're going to set the folder structure, as well as the key value pairs that you're going to be using for each scan. So for instance, if we wanted to create a key for our T1 weighted scan, let's create a key for our T1 weighted scan. So I'm just going to call it T1W equals create key, and then parentheses here. Then inside this create key, I'm going to give it the full path to what I want that T1 weighted image to be named as when it's converted to the nifty format. So it's going to start off first off with the subject folder that it's being assigned to. So we're going to say sub dash, because the folders for the subjects all begin with that sub key. So it's going to be sub dash, and then inside, like we did in the HeuDiConv command, we're going to use anything that's variable either across scans or across subjects. We're going to insert that in these curly braces. Okay, so we're just going to put subject in here. So sub dash curly brace subject. And the key is going to know to insert the subject tag, or the subject value for that key value pair into that spot. We also know that T1 weighted images need to be stored in the Xnap folder. So we're going to say sub dash subject slash Xnap. And then this is where we're going to set the name. Okay, so we know that based on earlier, the T1 weighted images have to have the sub key in the file name as well. So we're going to go ahead and add sub dash subject. It also needs to have the suffix on it. And it would also need a run number if we had multiple runs. It would also need a session number if we had multiple sessions. But for our data here, if we go back into our data, we only have one T1 weighted image. So, and we don't have any session information. So I'm not going to include the session information or the run information in the name. All I'm going to do is say T1 weighted.nii.gz as the suffix. Oh wait, no, I don't actually. Sorry, I don't need the nii.gz tag on there. I only need the T1 weighted tag on it, the T1 weighted suffix. And let me just make sure that I got the tag correct real quick. I can never remember if it's a lowercase t or an uppercase t. So let me go back up here. It is an uppercase t. Okay. So T1 weighted there. So that's the full key for any T1 weighted image that's assigned in our data set. We only have one, so we know that it's going to be named sub-subject number, so S01 in this case. It's going to be stored in that subject directory. It's going to be stored in the Xnap subdirectory, and it's going to be named sub-S01_T1W. All right. So we've done this for our T1 weighted scan. And now we need to do this for all of the other types of scans that we have. And what I mean by type is in our data set, we have, so what would we do if we had a T2 weighted as well? So what you would do is if you had a T2 weighted as well, you can copy paste this line. And you can change this to T2 weighted and T2W there. All right. So the T1 weighted and the T2 weighted are different types of scans. So we would create different keys for them. And what's important is that at least one thing, the suffix, has to be matched to the variable that we're sending. All right. So I'm going to delete this since we don't have a T2 weighted key, or since we don't have a T2 weighted scan. I'm just going to go ahead and remove that. Okay. But so we create a specific key for each different type of scan in our data set. What I mean by type of scan is that even though we have two resting state scans here, these resting state scans are the same except for the phase encoding direction that they were acquired. They're both, one of them is AP, acquired anterior to posterior, the other is acquired posterior to anterior. But we only need to create one key for them because we can insert the type of the phase encoding direction as a variable in the key. So what we can do is say rest equals, we're going to create it very similarly to the way that we did it before, the T1 weighted. So rest equals create key sub-subject, so same as before. But this one is going to go into the func folder, okay? Because it's a functional scan, it's going to go to the func folder. So make sure that you're not sending it to the Xnap folder, you're sending it to the func folder. The name of the functional scans start off with sub-subject, just like the T2 weighted or the T1 weighted scans did. The resting state scans, is there a way to exclude folders when scans had to be repeated due to motion, which would give 2 or more T1 folders? Yes. Okay, so there are ways to do it, and we can take a look at that in the DICOM info. In the TSV file, I think there might be a way to tell if, actually, I'm not totally sure. So what I would say is that you can, okay, for scans that had to be repeated due to quality purposes, where you're excluding the first one, there are a couple of ways to manage that. You can either convert all of them and then have a note for people that are using it in like the README files. You can add a README to all of the subjects saying which folders or which converted scans are good to be used. Or what you can do is have actually, one thing that you could do, think about if you do this. So let's say, for instance, we had a second T1 weighted in MP range, or actually, let's just do this Pinnacle field now because it's going to create it. It's very. So say we had another scan here, and it was, I'm just going to rename it real quick. It's just like 10. So we repeated the spin echo field map right after the first one. So it just came right afterwards. Spin echo field map 9 here, this first one wasn't for whatever reason. What we can do is instead, before the conversion happens, we can create an unused folder inside this directory and move it into the unused folder. Because what's going to happen is that whenever you execute, if we pull up the HeuDiConv command again, what's important here is this -d pointing to all of the DICOM images. The way that we've set up our path, it's going to go into the subject folder, and then it's going to just go into the first level of all of these subfolders to find the DICOMs that you need, find the DICOMs that you're wanting to convert. However, if you go into this unused folder, there's no DICOMs in this first level of the unused folder. So it's not going to see these DICOM images down here, if that makes sense. So that's a way to get around it. You just create you create an unused directory in that folder and just move the scans that you're not wanting to convert into them. And then just make sure that whenever you're running the HeuDiConv command, that you've structured this path in such a way that it's not going to go into the second level folders to find those DICOM files that you are not using. Another thing that you could do is just have a separate folder elsewhere in your system for unused scans and move them all there so that they're not inside this DICOM folder. There's a couple of ways around it if you want to do that. So if I can delete that. Rename this back to what it was. Okay. So, all right. So let's take a look at this heuristic file. Okay. So we're creating this resting state key. So if you remember from the key previously, all functional scans have to have a task ID with them. So we're just going to say, because we only have, because these are specifically resting state scans, we're just going to say task-rest here. So we're not going to have, oh, that's tasks. We're not going to have a variable here because all of the resting state scans are just going to be a resting state task. So we're just going to set it to be resting. In addition, because we have multiple runs of resting state, we're going to add the run key. And because they have different phase encoding directions that we want people to know about whenever they're using them, we're going to add the direction key as well. So we'll do _dir. The direction is going to, I'm sorry, I've left my email, so let me just get rid of that. Sorry about that. So you have, oh wait, and task rest _dir, yeah, dash, and inside this, we're just going to put a direction variable. So whenever it's going through and sorting through all the scans, it's going to know to put the direction in there based on what we do inside the for loop later on. Okay. Then same thing, kind of the same thing for run. So we're going to add the run tag, and then we're going to add something slightly different. As opposed to putting run in here, we're going to put a tag in here called item : 01D. Okay. So what this is going to do, and you'll kind of see it in the for loop whenever we work with that later. What that's actually going to do is it's going to say, okay, the name of this type of scan is kind of the same. Instead of putting the name here, I'm going to put an incrementing value going from 1 up to whatever number in this space instead. So it's going to be run-1, run-2, run-3, 4, 5, depending on how many resting state scans you have. It's going to put that in here, okay, for the run number. And then on the end of that, since those are all the key item pairs or key value pairs that we want to add here, we can add the suffix being bold, okay, because these are all bold scans. Now for each of the resting state scans, if you notice in here, for each of the resting state scans that we also have single band reference volumes that are associated with those scans. So we're going to create another key for the single band reference volumes that go along with our resting state. So all we're going to do is say, instead of being a rest equal create key, we're going to say rest underscore SV ref. So the single band references associated with the resting state scans. And the only thing that we're going to change in this is going to be this at the end from bold to SV ref. Okay, they're going to be stored in exactly the same spot, so in func, and they're going to have the exact same name so that we know which scans match, which single band reference volumes match to which bold scan. They're going to have the exact same name, except they're going to have SV ref as opposed to bold. Okay, so very easy to deal with single band reference images associated with functional scans and with diffusion scans. So we've gotten our T1 weighted image and all of our resting state scans out of the way. The remaining scans that we have are the diffusion weighted scans as well as the spin echo field maps. Okay, so we're going to do the diffusion weighted image next because the DWI image is actually very similar to the resting state. So we're just going to copy this down here, copy paste it. We're going to change rest to DWI. The DWI images are not stored in the func directory. They're stored in the DWI directory, so we're going to change that. And then the DWI images do not have a task key value pair associated with them, so we're just going to remove that. And then at the end, we're going to change the suffix from bold to DWI. So now you can see that we have created a new key for our DWI image. It's going to be stored in the subject folder, the DWI subdirectory. It's going to be named sub-subject. It's going to have the direction associated with it because the directions in here, for this data set, we took multiple diffusion scans in multiple directions. I just didn't want to add more scans to it to cause more bloat, but just for good practice, we'll add in the direction information to the scan name, and then the same thing for the incrementing run number. Now, because we have a DWI scan and the DWI scan has an associated single band reference volume, we're going to do the same thing that we did for the rest SV ref. We're going to just change that tag to SV ref there and add SV ref to our variable, to our Python variable for the key. Now the last one is going to be the spin echo field maps up here. So the spin echo field maps are both an individual type of scan. The only thing that changes between them is the direction. So what we're going to do is we're going to create an fmap variable. We're going to create a key for it. It's going to be structured in a very similar way to all of the other keys. So sub-subject / it's going to go into the fmap folder, not into the func folder, not into the DWI or NAP folders, but into the fmap folder. And then it's going to be named pretty similarly to the other scans. The one thing about this is that for spin echo field maps that where the way that you use them is that you collect two of them, one in one phase encoding direction and the other in the opposite phase encoding direction. Then you use these to unwarp bold images or API sequence images. Because the direction for these is necessary, you have to include, for spin echo field maps, you have to include the dir key value pair. So we're going to add that in here, dir-dir, the variable, and underscore, I think it's EPI, if I'm remembering correctly. Okay. So we just have subject, it's just going to be named sub-subject number, dir-direction, and then have the EPI tag at the end. Okay, so those are all the keys that we need because we've gotten our T1 weighted key, we've set that up. We've set up the rest and SV ref keys for those types of scans. the DWI and that type of SVREF, the associated SVREF for that type of scan, and then the field map. So we've completed all of our keys. Now you might be wondering, okay, so both of the types of both of the types of functional scans that we have here that are going into the func folder are resting type scans. What if I had a task related scan as opposed to, and resting state scans at the same time? There's multiple ways to handle it. You could use the same key that you used for rest for all of the functional scans. All that you would need to do is replace this task name with like a task variable that you set in the for loop later. I would not necessarily suggest doing it this way though, because that can cause some confusion for somebody reading your heuristic later on. What I would suggest doing is just copy pasting these two lines here, down here, and then change the task ID to be the name of the task. So if we were doing like an emotion recognition task, it would name it emotion instead. Oh, whoops. Oh, wow. That was bad. Name it emotion, and then just change these names up here to like emotion. Oh, geez. These. Yep. And then emotion here. So you can, for each type of functional scan where you're doing a different type of task, you can just copy paste these different keys and for each type of task that you have. All right, that's how I would suggest doing it, but it's kind of up to you whether you want to do it that way or whether you want to have a more general key and somehow extract the name of the scan from the name of the DICOM sequence and input it in there. It's just kind of up to you. But this is my personal suggestion. So since we don't have an emotion task in our thing, we are going to go ahead and remove that. And then the last thing that we need to do up in this section here, first, we're going to delete this data call because it's not important. Second, we're going to edit this info field here. So this is creating a dictionary that is assigning, it's essentially a series of buckets that we're going to drop the each of the scans into to assign them to different keys. All right. So we just need to create separate entries for each of the keys that we've created up there. So T1 weighted colon brackets. Okay, square brackets. And then rest colon square brackets, and so on and so forth. So I'm just going to copy paste and edit them as we go. That's the number that we need. So we have a rest, we have a rest SVREF, we have a DWI key, we have a DWI SVREF, ref, and then we have a field map variable. Okay, it's based on these variables over here. Okay. So that's all we need to do within this section here. The next section, so I'm going to go ahead and save that. The next section that we need to edit is the for loop. So in the for loop, I'm just going to go ahead and delete this large comment because I feel like it impedes a lot of reading because it's just so huge. Actually, up to this point, are there any questions about creating those keys? Doesn't look like it. If you do have any questions, feel free to go ahead and submit them, and I will see about answering them as they come in. Okay, so inside the for loop, what's going to happen is that there was another file that we created earlier. So let's go up and look at that. We also created the DICOM info TSV file that we have not used yet. We've only used the heuristic. What's going to happen is that during conversion, it's going to go through, the for loop is going to go through, I believe, through this TSV file or through the list of the scans. And what it's going to do is, based on specific qualities, specific matching qualities, it's going to assign each of these individual scans to one of those buckets that we created, one of those keys that we created. Okay, so first it might start off with the spin echo field map. And what we need to do is create matching criteria to correctly sort the spin echo field map into that fmap key that we created. In addition, this is going to be the point where we are going to set the direction. Okay, we're going to set that direction variable inside this for loop. So if I'm going to do that, and then over here, and then okay. So the DICOM info, what it's done is it's gone through and extracted a lot of relevant metadata about the scans. So you've got, for spin echo field map AP, you have 3 specific DICOMs in it. It has a 104 by 104 by 72 matrix of voxels, and then there are again 3 volumes. All right, TR is 8, TE is 66, and so on and so forth. Okay. It gives a few other things that you can get out from the DICOM info. And we're just going to use a couple of things to match on. Okay, you don't have to match on literally every single one of these pieces of information. You just need enough to make it to where it's unique, where each of these scans is going to be assigned to. Okay, so for instance, let's say that we are sorting the T1 weighted MP range. What are the defining features of the T1 MP range that differentiate it from all of the other scans in this, directory? So one thing is that it has T1W MPR in the name. So we can match on that. We can also match on things like the number of dimensions, the TR here, the TE, whatever else we want. What we can do for this one is just say if s.protocol name, if T1W in s.protocol name. If T1W is inside the protocol name. So that is a defining feature of this scan. No other scan has the T1 weighted T1W tag inside the protocol name. What we're going to do, if it's done with that, we're going to say info dot T1W equals s dot let me just make sure, I think it's actually series ID. We're going to assign the series ID into the T1 is that right? Sorry, I'm not especially great with Python, so I am going to go find the one that I created previously and just make sure that I'm doing it correctly. I want to tell you all. So we're going to the same. Oh, whoops, I'm in the same directory. So down here, info, okay. Not dot, sorry, I get confused on the assignments in Python. I'm not great at it, so I apologize for going wrong there. So info, the T1 weighted bucket inside this info directory, it's going to be assigned s.series ID for it. Now, one other thing that you might want to do for these T1 weighted images, at the very least for the scans, for the sequences that I used on Prisma here at UAB, whenever I ran the T1 weighted or T2 weighted images, it actually output 2 separate images for each one of those scans. What it output was an intensity non-normalized version and an intensity normalized version. So for some people, they want to use a specific one of those scans for, let's say, FreeSurfer for surface reconstruction. I always want to use the intensity normalized version. So you might be wondering, how do you tell the difference between the intensity normalized version and the intensity unnormalized version? Well, if you open up the DICOM info.tsv here and go to this image type, what we can see is that for the T1, it has a tag inside this image type here for norm, okay? That means that it is intensity normalized. The non-normalized version will not have that tag. So another matching criteria that we can use for this is say and norm in s.image type. All right. So get me the scan, or if there's a T1 weighted tag inside the protocol name and there is norm inside the image type, then assign this scan to the T1W bucket inside this info dictionary. Okay, so that's how it's going to know for this. It's going to assign this series ID to be named based on this key up here. Okay. All right. Are there any questions on that? I know that might be a little bit strange. Thinking about that, especially for people who haven't used Python or are new to coding. Are there any questions on that right now? All right. So I'm going to go to this one. It's not. Or actually, we'll leave that for just a second. Okay. So now we need to go and make keys for, or we need to go and make assignment statements for these other scans as well. So this is again just going to be another series of if statements here, and again these if statements need to be unique. So we did our T1, and then we can start off with if, let's say we were doing the resting state scans, okay? One of the things that defines our resting state scans, and specifically the actual bold sequence, not the single band reference volume, specifically the bold sequence, is that we can match on the fact that there is a rest inside the protocol name. So if rest in s.protocol. Now, if we just did this though, it's going to match based on, or it's going to match the single band reference volumes to the rest bucket as well, which is not something that we want. So we need to add a second criteria here. We're going to add and the s.dim4, which is the number of volumes inside, which is the number of volumes in the scan. S.dim4 equals, or double equals, sorry, 420. All right, because there's 420 volumes inside the bold sequence here for this resting state. And then one thing that we want to do is, since we're changing the direction variable as well, we want to match based on the AP, okay? Based on the AP name. So we can add yet another matching criteria and s dot, and AP in s dot protocol. Okay. So if I bring it over. So this is the string of matching criteria that we're going to use to assign resting state scans to this resting state key. Okay. So we'll add our colon at the end here. We'll say info rest equals, then, or I'm sorry, not equals. We're going to say instead here dot append. So the reason that we're doing dot append instead of equals here, the T1 weighted image only has one image in it for the entire session. Whereas the resting state scans are going to have multiple, and for a full session of this, the diffusion scans would be multiple. So we're going to append multiple ones to this bucket, okay? So we'll say append, and let me make sure that I'm getting it correct in here. Yeah, it's all inside. So inside here, we're going to be, because we need to insert the direction and the run number into it, we're going to assign inside the dictionary, we're going to assign first off item inside this quote item colon s dot series ID. Okay, and then we also need to assign the dir variable. So we're going to assign the dir here. Because this is AP, we're just going to assign it to be AP because that's the criteria that we matched on up here. And that should be everything that we need for that. Okay, we just need the item being the series ID, and then we need to assign the direction. Now we can do this. We can copy paste this again for the PA. The only thing that's going to be different between the AP and PA here is just changing this direction right here from dir being assigned to AP to dir being assigned to PA. Okay. All right, so we've created matching criteria for all of our types of resting state scans. Now we need to do it for the SB ref. So let me go ahead. I'm going to separate these out. Resting scans. Then I'm going to copy paste this because the magic criteria for our single band reference volumes are going to be very similar. So resting SB ref. I will say, setting all of this up, setting all of these magic criteria up, I'm doing it in a very verbose way that is not very, it's not very concise. People who are better at Python than I am could make these magic criteria much simpler and assign like the task and direction and differentiate between SBRef and AP all at the same time if they wanted to. But I'm making it a little bit more verbose because I think it's a little bit easier to understand and read later on. So that's why I'm doing it this way. Take that out now. And then since we're assigning to resting state SBRef volumes here, info, we're going to change this to info rest underscore SBRef to match the key that we made up at the top. Same thing down here. We're again appending items. We're appending the item being series ID and the direction being AP, or PA. The only thing that we're changing here is that the dimensions that we're matching on are going to be 1. So dim4, there's only one single band reference volume. So that's what differentiates the single band reference volume from the main bolt scan, is this value of the fourth dimension here. So we're just going to change our matching criteria to be sdim4 equals 1 in both cases. All right. So we've done our T1, we've done our full resting scans, and we've done our resting state single band reference volume. Again, the last things that we have left are the diffusion scan, the diffusion single band reference volume, and then our field maps. Okay, so we'll go ahead and make another small section here. We're going to create our diffusion matching criteria. So if, and in this case, one of the things that differentiates diffusion from the rest of the scans is that it contains this DMRI tag. So we can just say if DMRI in s.protocol name. And then, and based on the matching criteria from before, again, we have the problem of it being assigned either the single band reference volume or being assigned the main diffusion sequence. We'll say, and since we're wanting to do the main diffusion sequence here, we'll say and s.dim4 double equals 100 in this case, because there are 100 volumes in this diffusion sequence. Okay. Normally, if you would have multiple diffusion scans that have the same number of volumes but have different phase encoding directions, you would, similar to how we did it with our full resting scans up here, you would also add another matching criteria for and AP in S dot protocol name. Okay, you can do that as well. We'll do that here just because it's more verbose and it's more representative of what we would do if we had that extra PA diffusion scan. So we'll leave it in here. All right, so we have all of our matching criteria. We'll do the same thing that we did before. Just grab info rest, just copy paste it in here. Change the specific assignment to DWI. Assign the item being the series ID like before, and assign the direction being AP. So again, those are the only things that we really need for this. For this diffusion scan up here is just the direction and then the run number. Okay. We're going to do the same thing that we did for the single band reference volume for the diffusion scan as what we did for the functional scan. So let's just go ahead and copy paste this down into here. Change this to 1. All right. It's the only thing that we need to do because we only have one AP diffusion scan and only one AP single band reference volume. We just need the assignments for those. Then last but not least, we'll do our field maps. Okay, we'll do our field maps. So I'll try to get through this a little bit more quickly. So matching criteria based on those. The defining characteristic is that it is named spin echo field map AP and spin echo field map PA. So I'm just going to match on that. We could definitely just condense a lot of these matching criteria down to just be based on protocol name, but it only necessarily works if there's not multiple of the same scan in there. So that's why we do the all of these other matching criteria. Okay, so for the field map, if spin echo field map AP, I'm just going to say AP in S protocol name. So that's going to be the only matching criteria, and I'm going to create one for both the PA and AP directions here. Okay, so that means info fmap equals, dot append. And then the item is going to be the s.series ID. And then again, we need the direction in here because that's the one of the other variables that we're inserting to our field map key. We need dir as, in this case, AP, because we're matching on the AP direction. Oops. There we go. And then do the other one for PA. Down. Switch to speed. Okay, so that's the full matching criteria for all of the scans that we have. It's going through and assigning each of those scans and the variables that we need to insert into the keys. It's assigning all those to the specific locations inside the info dictionary that we created up here. I know that that's a lot and it's kind of confusing getting that set up. Are there any questions here before we move on to actually using this heuristic file? So one thing that's very good about the heuristic files is that once you create one for one session or for a whole whole data set, you only need to create it once. You don't need to create it for each different subject because ideally all of the subjects would have the same scans run. They would all have the same types of scans. You're not adding a new scan into subject into the middle of the protocol while you're collecting participants, they should all have the same scans, and so they'll all use the same heuristic. So setting it up is time consuming at the very beginning, but it's eminently reusable for every subject in that data set. So like I said before, I'm putting, for people that weren't able to copy down everything in this file into their own, I put the heuristic file onto the box folder. And again, for everybody, I'm going to put it up onto a GitHub link too, and I'll send out all those links later. So you can use the same heuristic file later on if you want to, compared to what you have here. Doesn't necessarily work. What I will say is that when using this tool, any errors that pop up in naming is almost always attributable to the heuristic file. So that should be the first place you look whenever any errors crop up, whenever the conversion actually happens. Okay. So if there aren't any questions about this, we can go ahead and start actually converting the files using this heuristic file. And what is nice, when a scan has to be truncated, but we still have to use the remaining data, say only the first only 300 first TRs of rest, can we still use it? Okay, so what I would say there is if there is truncation, the DCM to NIIX tool, I think, goes in and calculates how and finds out how many volumes there are supposed to be. And so just removing the DICOMs for the specific volumes that you don't want, I don't think that's going to work because I think it'll throw an error. What might be easier to do is to just convert all of the scans in full, and then later on go through and edit the nifty files that you have to remove the volumes that you want to remove. So I would still just use any sort of matching criteria or anything. I would use the number of volumes that you have in the full sequence, and then do your sequence editing after conversion. So doing the actual conversion is pretty straightforward. From this point on, since the HeuDiConv heuristic file has been created, what we can do is just I'm going to clear. Oh, sorry. I'm going to clear that so it's a little bit prettier right now. All I'm going to do is pull up that same command that we had previously. What's nice is that pretty much the same command can be used, except we're just going to change a couple things. The subject name, DICOM path, and output path are all going to be the same. The only things that we're going to change are -f. So instead of doing convert all, we're going to give it the path to that heuristic file that we created. So it's going to be dspath /heuristic.py, okay, because that's where it's stored. In addition, we're going to change the converter to be DCM2-NIIX. And then we're going to add that -b option, telling it that we want it in BIDS format. Okay, so that's the only thing that we need to change in this function call. And I'll go ahead and copy paste this into the chat, just in case people have transcription problems. Oh, wait. There you go. Okay. So we'll go ahead and run this. So it should take a second. It's going to go through all its basic standard setup. Yep. Okay. It's running the version. So it's going to take a little bit. At this point, this would be a good time if there are any questions for anything like that, because it's going to take a minute for it to convert all of those files to nifty. Let's see if there's anything else. So you can see that it's starting to convert here. Let's go and take a look. That's in the desktop. So you can see it's created a PyCache folder here for the stuff that it's doing. That doesn't need to be interacted with, it's fine. We can go into Nifty here. One of the things that happens, okay. I'm not exactly sure why this happens right now, but sometimes whenever you're converting the first time, it just kind of messes up and just writes all of these run numbers. What I've found though is that if you just delete the contents of the folder, including the HeuDiConv directory, you don't need that after you've created the heuristic file, you don't need that anymore. Once you delete, if you just delete that stuff and run it again, it typically works. So I'll just restart that. I apologize. I don't know why that happens right now. I think it might be because I think you might need to delete the HeuDiConv folder before you run the conversion again. But it's just kind of it's a really strange error that I'm not sure why it's there, why that happens. But like I said, you just delete the incorrectly named files, delete the HeuDiConv folder, and then run it again, and this starts screwing up. Oh, no, okay. So you can tell it's starting to do it correctly this time. It has created the sub-S01 folder here. We go into it. It's created the Xnap folder here. It's created the func folder here. It's also got a sub-S01_scans Json file and Tsv file listing off the scans that it's converted. So that'll contain all of the scans in the session at the end. If we look in our Xnap folder, we can see that we've got, if we compare, actually, we could bring up Heuristic here. Bring up the heuristic, go back into the, go back into the Nifty folder, go back into here, in Xnap. You can see that in our key, we named the T1 should be named subject/Xnap/sub-subject_T1 weighted. You can tell it's done that perfectly. It's named sub-S01, so that subject name has been inserted there. It's got the T1 weighted suffix on it, and you have the nii.gz file as well as the corresponding JSON file. So the JSON file has been created automatically. It's you don't have to do anything for that on your own, which is just great. It's amazing. It's still converting a couple things. So same thing here with the resting state scans. Those are being converted currently. So it just got done. It just got finished converting the AP resting state scan that we have. So it's got the name that we had for it. We created the key up here for rest sub-subject/func. So the func folder /sub-subject_task-rest. So we've got sub-subject_task-rest. It has correctly inserted the direction key pair, and it's got the run number labeled as well. One thing that you'll notice here is that run one, the run number is incremented for every resting state scan that occurs. So if we go back to the DICOMs, you'll see that the way that we had it was rest01 AP and rest01 PA. So they were treated as kind of like two halves of the same resting state, where one was acquired in PA direction, one was acquired in AP direction. For the BIDS naming structure, that is not valid. The run number should be incremented for every resting state scan. And so that's what's happened. We've got rest1 here because that was acquired first, rest2 here because that was acquired second. And then the direction is just a modifier for it. Okay. So go back in here. We've got our direction AP run 1 for the bold.nii.gz, the bold JSON file as well. In addition, it also creates the events.tsv and events.tsv file. So you've got the onset, duration, trial type, response type, stimulus file, and then you need to fill in the rows and add more tab separated columns if desired for it. There are instructions on filling out this events TSV file on the BIDS specification page. I would highly suggest reading through that for event-related designs or block-related designs. It's not just event-related designs, right? You can set out the timing for the beginnings of blocks for block-related tasks as well. So you fill all those out in the events TSV file here, okay? We've also got our SVRef JSON file and our SVRef nii.gz file. So even the SVRef also gets a corresponding JSON file with it. So that's fine. So you'll see there's like 5 files that I would associate with a single resting state run. You have the bold file, the JSON file associated with that bold file, the SVRef file associated with the resting state file, and that SVRef's JSON file, and then the events file. For resting state scans, you do not need to fill out anything in the events file because there's no event in a resting state scan. Okay. So we've got that for our run 1 and run 2. So those have both been fully converted. We also have our DWI. While I was talking about that, our DWI images got converted. Yeah, something's. You can see we've screwed this up. We've screwed the pooch on this one. So the reason that I say that, in the DWI, we only had one diffusion run, right? And then we had the SVRef run. So what's happened is that this run 1 up here is actually the SVRef, the single band reference volume for the one diffusion run. You can tell that because anytime a diffusion run is converted from DICOMs to nifties, they also create VVAL and VVEC files associated with it. And this does not have associated VVAL and VVEC files. So that's the single band reference. So we need to go through and figure out what we did wrong in our DWI that caused it to be named incorrectly. And it is because in here, this is the single band reference, right? Because we are matching criteria based on the 4th dimension being 1. So that's the single band reference. But we did not assign it to the DWI_SVRef bucket because I moved a little too fast, if you can imagine. We need to do that for it. So info DWI_SVRef. That should fix the problem. So we'll just go ahead. I'll finish explaining through this, but what will happen is that whenever we rerun this file is the main scan. It will just have run 1 on it. And then this will be renamed to DWI. If I just did it manually, let's just do it manually. This DWI would become SVRef. This DWI here would become SVRef. And then all of these runs here, all of these runs, I wonder if I could rename it batch. All of these runs will be renamed to run 1. All right. So like I'll just do it once, but all of these are going to be. So that's how the DWI image is going to be stored. And then you would have the field map. So the field map, you have the AP direction, the PA direction, and then their corresponding JSON files. Okay. So we only had 2 we only had 2 spin echo field maps. We've got 2 of those scans as well as the corresponding JSON files. So I'm actually going to go ahead and I'm just going to delete all of this real quick because I messed that up, and it's just going to be easier since we only have one subject here. It's just going to be easier to delete everything and rerun it. We've saved the heuristic, so it should be correct this time. In the meantime, I'm going to go ahead and talk about a couple of other things. So we have the data in our, we will have the data in BIDS format. Okay. there are a couple of things that we're going to have to do a little bit of cleanup at the end. For people paying attention to it, whenever I had the files up on screen, for a lot of those files, you might have noticed a little lock icon on the file icon. There's a little lock on it. What that means is that by default, HeuDiConv only outputs files that are at least associated with the scans as read-only. Okay, so you can only open them up and look at the information there. You can't edit it. Unfortunately, this is not especially useful for things like fMRI prep, where fMRI prep is reading all of these scans, and it requires for some of its processing, it requires a write permissions on these DICOMs, or I'm sorry, on these nifty files. So what we're going to have to do is, it's easier to just add user and group write permissions to all of the files, and keep a separate copy of the DICOMs elsewhere in case they need to be, in case somebody deletes the BIDS formatted version. You can regenerate the BIDS formatted version very easily, as long as you have the heuristic file that was used for mapping, as well as the original DICOMs. Okay, so we're going to go ahead and add write permission. As soon as this is done running again, we're going to go ahead and add write permission to all of the files. I'll show you. It's a very simple command to do. I'll show you how to do that in a second. All right. I know that's been 2.5 hours already. It's taking a little bit longer than I thought it was going to. Are there any questions up to this point?
Hey Matt, this is Meredith from Auburn.
Finish.
Matt, can you hear me?
In the meantime,
Wait,
there
the
aren't
rest
any
of us can
questions
hear
right
you,
now,
but Matt can't
because
hear
there
you.
might be
Oh, I'll put it in the
some,
chat.
People might be getting. Yes, Christina. Oh, wait, my speaker's not on? Oh,
We're trying to talk to you and it doesn't seem to be working. Can you hear us? I'm speaking.
oh
Can you hear?
no, sorry, I don't know where the, oh, so my microphone's on, I don't know where the speakers are for this. I can't hear.
We can talk to each other then. Haha. And then
Sorry.
we can determine what to say together.
Oh, there it
Yes,
is. I
recording
got it.
is
I had to switch it. I'm sorry. I can hear people now.
Can you hear now? You can hear me?
Yes.
Okay, Meredith, can you?
Yeah, I was just asking if you'll make the recording available. And
Yes.
then could I maybe email you to get the link to that box folder that you mentioned and all that stuff?
Yes, absolutely. I'll send out the box link and the GitHub, whenever the GitHub repo is made, I'll send the links, all that out to everybody. And I'll make sure this time that all of the Auburn email addresses that signed up, that actually the email gets sent this time.
Okay. Perfect. This has been really helpful.
And if you could, maybe if you could distribute it or have somebody at Auburn distribute it.
Yeah, absolutely.
That'd be useful too.
Yeah, perfect. We can definitely do that. This has been super helpful. I really appreciate it.
That's good. I'm glad that I'm glad that some people are getting something useful out of it. All right. Okay. Are there any other questions? If not, so this just got finished, but just briefly, everything that I've talked about, I've got slides for it on, I've got slides for it obviously that I was presenting from earlier, but there's also documentation that I've written up on our website. So cinl-docs.readthedocs.io. This is a very rough website right now for documentation that we think that the CINL thinks is useful for people doing neuroimaging analysis. So let me go ahead and bring up the chat real quick and put it in here. It's got information on Xnap, BIDS, BIDS conversions, as well as example scripts that I've written up. And fMRI prep, using fMRI prep, like what it is, how to use it on Chiha, and then the example scripts that I've written up for that as well. So if you all want to go there and look at that information as well, that could also be helpful. If there's a lot of stuff that I want to add to this over time, if anybody has suggestions or requests for things to add to it, there's an associated GitHub repository for these docs. If you want, you can go to the discussions and we can create a discussion here for things people may want to add to it. Okay, and I'll try and get around to them. I can't promise I'll get to every request because some of them might be beyond me, or I've got, might take a little bit of time to get things up. But I would love to make that a repository for especially new graduate students coming in or postdocs that are new to neuroimaging analysis. Make that a repository for people to go in and get at least like some basic introduction to getting started. All right, so you can see we've got our first BIDS subject here has been created. You can see that it's also auto-generated the modality agnostic files that I was talking about earlier, the dataset description as well as the participants, Json and Tsv files. It's also created a rest bold JSON file here. I'm just going to open it up and see what it looks like because I haven't actually looked at this before, I think. Oh, okay. It's got, these are like as opposed to, if you wanted information on the metadata for any given task, as opposed to having to go into a specific subjects folder to find it, it's going to create a JSON file for each unique resting state, or I'm sorry, each unique bold scan in the main BIDS directory here, in the top level of the BIDS directory. So you can find it there. Okay, so just to reiterate kind of what I was talking about before with the locked files. So you can see the little lock icon over here on the far left. It means that it's read-only. If I opened up a terminal here and did an ls-l command, so look at the permissions, you can see that you can see over here on the permissions, you only got read-only permission for user group and everyone. So you can't do any editing. So what we're going to do as part of the cleanup after BIDS conversion is we've got our, we're going to change directory to the dataset directory path. And then we're going to CD to the nifty, CD to the BIDS sorted directory, the nifty directory. We can execute one easy to use command to give write permissions to both user and group. So that's going to be find, and then you give it the name of the subject that you're wanting to do this for. So sub-01. You can give it a type F being, set the type to F meaning file. And then we're going to have it execute. So it's going to find every file inside this subjects directory. So everywhere inside Anat, DWI, FMAP, and Func, as well as these two JSON TSV files down. It's going to find every file. We're going to execute a chmod command. We're going to include brackets. No, we're going to do U plus GW. So you're adding user and group write permissions. The brackets here are go through every file from the find command. Sorry, I touched the screen. Go through every file from the find command, insert it into the chmod, and run the chmod command for everyone. That's what those brackets mean. And we're going to end it off with a semicolon and a backslash, because that is, or a backslash semicolon. oh wait, sorry, it's UG plus W, not U plus G. User group plus right. Okay, so dash exec chmod UG plus W, so add right permissions to user group for every file from the find command, and do that over and over. So once we go back into the func folder here, you'll see that all those locks are gone off of all of the files. If we run the ls-l command, you can see that right permissions have been given for user group. Okay, that's what we want for fMRI prep to be able to run correctly. It needs to have those right permissions for the relevant files. Okay, so at this point, you've got your data set in BIDS format, or so you think. One good way to check is by opening up an application, opening up the web browser. And what's handy is that there is an online BIDS validator to validate to tell you that you sorted your BIDS files correctly, all right? Sorted and named them correctly. So what we can do is go to this bidstandard.github.io /BIDS validator. You can click browse, and then we're going to go to the Nifty directory here. We're going to select the Nifty directory because that is that's the BIDS sorted directory. And we're going to say upload. Now, upload might scare you because upload might mean that you're sending like actual scans up into the website, but that is not the case. We're not sending any scan information up to this website. It's not reading anything as far as the actual image goes. All it's reading is the directory structure and then the name of the scans themselves. Okay, it's not reading any information from any of the files, so it's not getting like PHI such as age from the participant's TSV file. It's just getting the directory tree and matching and validating that the directory tree that it gets to what it should be according to the BIDS system. And what we found is that there's only 2 warnings in my data set. So you can download the error log for Nifty and open it up with a text editor. And you can see that the warnings really only correspond to the fact that we have to fill out the events TSV file for the resting state scan, but we don't have to do that because there's no events. And then the same thing for the PA run 2. So those are the only 2 warnings that we have to do. Those are the only 2 warnings that it could find. It found no errors, so we don't need to do anything. Our BIDS, our data set is BIDS validated. It is correct and ready to go. So now, if we wanted to actually use this data set, and I'm just going to do this very quickly. I apologize for going over how long I thought it would take. The last thing that I wanted to talk about was fMRI prep. So on that CIML docs page, you go there. I've got fMRI prep, and I have example scripts here. I've got example scripts for running a single subject job, as well as running a job array, so running multiple subjects. I've written it in such a way to where, at least if you're using it on Chiha, the only thing that you should really need to change for the single subject is the dataset directory here, as well as the participant, okay? It does assume that you have named your BIDS validated directory Nifty as opposed to raw, which is what we might have seen earlier on in the presentation. It does assume that you named it Nifty instead, okay? So we can take this and we can copy paste into our window here. And in our folder here, what I would do is create a new folder called code. So this is going to contain any files or scripts that you have that are going to run any sort of pre-processing on the BIDS validated dataset. Okay. We're going to create, oh no, not a new directory. create a new document. We're going to call it fMRIprep.sh. Okay, this is going to be a shell script for running fMRI prep. We can open that up and paste everything in. So like I said before, what it's doing is it is going to actually do. Oh wait, no, user data is fine. We need to change the output directory to be bids_workshop/ws_data/code. And then it's going to be under S01-fMRI. Actually, out.txt. The job name will set to be just fMRI prep for now. The number of tasks that we're going to request is 1. We're going to request 4 CPUs for this task to run. fMRI prep runs FreeSurfer, and it runs minimal preprocessing for functional scans such as distortion correction, as well as registering functional scans to the T1 anatomical. So those sorts of processes, FreeSurfer especially runs better if you have more CPUs. So we're going to have 4 CPUs here. We're going to put it on the medium partition because we're just going to run it for 50 hours. The amount of time really depends on how many scans you have that you're processing. If you have a bunch of functional scans that you're processing, as well as doing T1, as well as doing FreeSurfer with a T1 and a T2, all of that can take a long amount of time. So we'll just say 50 hours for now. If it finishes earlier, it'll quit. And it'll be fine. Then the other things that we need to set are the dataset directory. So in our case, it's going to be bids_workshop/ws_code/data. All right, so that's our dataset directory. And the name of the subject is S01. Those are the only things that we need to change. There is one note here. We do need to, if you're running it on your own, you do need to have this FreeSurfer license file. I think that we should be able to link, you should be able to get the path to it, to it in the module, but it's better to really just copy it from the module file to your home directory, so you always have it, because who knows when we might take down some of the modules once they get very old or out of version. So go ahead and copy the license file from the FreeSurfer module to here, and I'll show you the command for that. Go back in here, find, so that's that. Oh, I forgot. There's one other thing that we need to do. We'll talk about that here in just a second. Yeah. Copy that. Sorry, it's not, you all can't see it, but I'll show it to you here. So, and I'll also post it in the chat. So you're going to copy the FreeSurfer license file from FreeSurfer 7.1.1 to your home directory. It doesn't matter which license file you have, like you can get it for version 6.0 or 5.3 or whatever. It's all the same license file. It'll all work. One license file will work for all versions of FreeSurfer. So don't worry about which one you actually copy paste here. It'll be fine. So you copy and pasted that. You have the license file. The last thing that we need to do, I forgot, as part of cleanup is we go back to our, and we have to do this after we make the JSON files readable. We go back to our subject here. We go into the fmap section. So for fMRI prep, you're wanting to apply a distortion correction generated from the spin echo field maps to the functional scans, to the DWI scans. However, there's not a way for it to really know that because it relies on a specific field in the JSON file that is not included automatically. So what you need to do is open up the JSON file, and then you need to add a field manually to it. And this is going to be, let me put it in alphabetical order. This is going to be the intended for field, okay? And you're going to create a list of files that this field map is associated with. So which files are you applying the field map, or applying the distortion correction generated from this field map to? In our case, we're applying the correction to both of the functional scans that we had, as well as the diffusion scan, okay? So the intended for field is going to be the func slash, this is going to be in quotes, func slash sub dash S01 underscore task dash rest underscore dir dash AP underscore run dash 1 dot or underscore bold dot NII dot GC. Okay. So it's showing up red for me, so I don't know if that I did it just correctly. Give me just a second to make sure that I did that correctly before I. Yes, so that is correct. I don't know why it's showing up as red. Maybe it's just, maybe it needs double quotes instead. I'm not used to things needing. Yep, okay, it just needed double quotes. Has to be double quotes. Not used to there being a difference between the two. So we're going to do that for all of our DWI, as well as the two old skins that we have. All right. So and then DWI. So it just needs to be the relative path, the path relative to the subject, acting as if the subject's directory as is the top level directory. Okay. So you get rid of that. Run 1 underscore DWI. Okay, so now that we've got the intended for field for the first field map, we're just going to copy and paste this and make sure it's exactly the same. We're going to copy and paste it into the other field map, okay? Because it needs to be associated with both. The intended for field needs to be in both and needs to be exactly the same. If you all have different field maps that you all use, I think it should be the same procedure where the intended for field should be the same in like the phase file and the magnitude file and whatever else you might have, depending on how you're doing your distortion correction. Okay, so we'll save that. So that's one of the reasons that we needed these files to be to have write permissions, is because we needed to add that intended for field. So now that we've done that, we are ready to run the fMRI prep command. This is a very brief walkthrough to the fMRI prep command. Sorry, again, this is getting a little bit late, but there's a few specific options that are mandatory. One, you need to give it a data set directory where your BIDS formatted data is. Next, you need to give it the path to where you want the derivatives output to be. So where is the fMRI prep and free surfer outputs, where are they going to be stored? In typical BIDS structure, you store them on the same level as the BIDS directory. So it's going to be dataset directory / derivatives as opposed to dataset directory / nifty. Then the last thing that you need to give it is a level at which it's performing fMRI prep. This is always going to be participant, okay? So those are the three mandatory inputs. The other inputs that we've got here, I'm setting up a working directory for it to put its temporary files in as it's working. I'm giving it the participant label is going to be S01, which is set up here. So that's the participant that we are running. It does not, notice it doesn't have the sub tag in front of it. It's just the ID, the key, the value for that key value pair. The output spaces are T1 weighted, so all of the functional data is going to be transformed into native T1 space. This has a lot of different options available to you. You can use M&I templates, various M&I templates. You can use various other templates of indeterminate origin. All of those are available in what's called template flow. There is information about template flow on the documentation, the CINL docs page, that links to template flow and how to use it. There's also info on template flow in the main fMRI prep docs as well. So if you're wanting to use a standardized space here and not just do the easy way and convert to native T1 space, go into and read about template flow and see what templates you have, what standardized spaces are available for you to use. We're also giving it the FreeSurfer license file because without the path to the license file, it wouldn't be able to run FreeSurfer. And then we're telling it that we have requested 4 CPUs. We were requesting 4 threads. And then we are also telling it to output in CIFT space because it's able to do that. So you're able to use it with like the WB command with the HCP Connectome Workbench Toolbox. It can auto convert to CIFT outputs. 91K here is the option that I put in. It actually refers to the 32K atlas. So for people that don't know, the 32K atlas for the Connectome Workbench means that there are 32,000 rate ordinates, give or take, on 32,000 vertices on the left hemisphere surface, 32,000 on the right hemisphere surface, and then some other indeterminate amount on for subcortical for the subcortical structures, and all of those add up to about 91K. So it's how fMRI prep says we are going to put the outputs on the 32K FSLR 32K atlas. I don't like it, but that's how they determine they're gonna say it. Okay. Sorry again for rushing through this at the end. So those are the only things that you really have to change about this script are just the dataset directory, the participant, and then the output spaces if you want to put it into a specific standardized space. From there, all we need to do is say we've got our code. We can open a terminal here and then do sbatch fMRIprep.sh, submit the job, and it will run eventually once the cluster finds enough resources for it. It's not a huge job, so it shouldn't take forever to schedule, but it is on the medium partition, which is one of the lower priority partitions. So it could take a little while to schedule. Okay. I would highly suggest running it on the subjects that we have. I would very much suggest doing that, seeing what the output of fMRI prep is, even if you're not going to use these data for anything meaningful, just seeing what the outputs look like is useful. Unfortunately, I don't really have time to do that and still leave time for any remaining questions before the at the latest I gave for the seminar was. So if there are any other questions, please type them in the chat. Otherwise, that is going to be it. Like I said, I put the various files that we used here into the box directory for everybody outside of UAB. I'll put these files into a GitHub repo, send the links for the GitHub repo and the box directory, and a link to the video, to the recording in another email separately. Okay. All right. Are there any other questions?
Thanks, Matt.
Yeah. Thanks for coming. This is the first one that I've put on. I hope to do a couple more, maybe not 3-hour seminars. But there's also, I should say, I'm going to shill for a second. I've got for anybody that wants to, that needs help with anything related to computing, especially on Chiha, there are research computing office hours Mondays and Thursdays from 10 to 12 on Zoom. Links can be found at the top of the rc.uab.edu page or at, let me go and find it here. you search UAB research computing, there is the page here. There are links to this office hours on this page as well. Okay, so I'll go ahead and add that to so for people that don't have access to Chiha to get that, you can go to that page as well and find the office hours if you need help. You can feel free to email me. I'm also giving an intro to R workshop for Research Computing Days on March 2nd. So for anybody that wants to learn a little bit about R, it's going to be covering the basics of the tidyverse. So manipulating some, or wrangling, I should say, manipulating is a bad word. Wrangling some tabular data sets, going through plotting and everything like that. That's going to be on March 2nd. So what is the directory for quality assessments of fMRI data at the end of the fMRI process? Okay, yeah, so one of the things that's nice about fMRI prep for people that are still here, if we go back into here, I've run fMRI prep on this subject before. So I'm going to go back to that data set real quick. And in this one, I put the derivatives in the BIDS folder. It doesn't really matter, but it's fine. So if we go into derivatives and we go into fMRI prep, you'll see that fMRI prep created both free surfer and fMRI prep derivatives. So the free surfer information is in here. All the non-free surfer information is in the fMRI prep. So we can go into there, then we can go into sub-S01. And so all the diagnostic information that you're going to want as far as stuff like registering functional data to structural data and how well that registration came out, they're going to be in this figures folder here. And you can see that they're named based on a specific way. So they've got the sub S01 task rest dir AP run 1. So this all corresponds to that one resting state scan. You can open up this SVG file, a scalable vector graphics file that has the actual registration for the bold scan with the T1. So if you open that up, what you see here, if we zoom in really far, is that you've got red and blue lines. So the blue line, both of these lines are created by the peel surface, by the surface borders for the white matter and peel surface from the T1 image. And then we've got overlaid under it, I guess, the bold sequence that came along with it, the bold sequence that was registered to the T1. And all you're wanting to do is make sure that these red and blue lines generally match the borders of the bold sequence, okay? So those are all in the figures folder for the fMRI prep output for the specific subject that you're wanting to look at. As well, there's also a couple of other things that are nice. So you've got you've got a carpet plot, you've got SVG. Yeah, okay. This is just the summary of the scan. This is very weird. There should be, yeah, okay. If we go into func, sorry, I was in figures. If we go into func, another thing that's nice that's output is the confounds. So just fine, sorry. They output a lot of stuff in here. So there's a time series. Just in the time series. I want to open the JSON file. Yeah, okay. So as part of the outputs of fMRI prep, it also outputs confounds, so global signal. It has CSF derivatives for the CSF, the white matter, and it goes through, or it performs a concord for you to use as principal component, or as component regression. It also gives you information such as like the frame-wise displacement from the first volume in that functional scan. So this is just a measure of how much they moved during the scan. And in absolute units, it doesn't tell you whether they moved left, right, up, down, or forward, backward. But it does give you a good measure of how much they moved. And this one, they did move that back. All right. Okay, I think I'm gonna end it there. It's almost 4 o'clock. Again, sorry for going 3 hours. I didn't expect it to go 3 hours. I'm glad that I told you all that it might go 3 hours though. So I'm gonna go ahead and end it there. If you all have any questions about it, please feel free to email me, and I will try and get back to you as quickly as possible. And I hope you all have a great rest of your day.
Matt, if there's interest in an fMRI prep only discussion sometime, maybe we could arrange to do that, have people get together at